The research examines why advanced AI models fail at simple reasoning tasks humans find easy. The authors introduce new benchmarks, including the Unpuzzles dataset, which pairs hard puzzles with easy versions to test for memorization versus true reasoning. The core finding is that making tasks easier doesn't always improve performance, highlighting ongoing generalization challenges in AI. Our goal is to better understand these failures to improve future models. The original puzzle is a classic logic problem where the initial numbers make the solution no. The unpuzzle slightly changes the numbers, making the answer an obvious yes. A context-shifted unpuzzle applies the same simple logic to a different theme to isolate reasoning from memorization. This setup tests if a model fails the unpuzzle by incorrectly recalling the solution to the original, more famous problem. To test LLM reasoning systematically, researchers created 4 task types that can be generated automatically. These include counting words or characters in a text, evaluating or negating first-order logic formulas, solving math word problems that can be complicated with irrelevant data, and creating a valid travel itinerary based on set constraints like cost and destinations. The tables show model performance on counting tasks, with difficulty adjusted by the number of words, K, and paragraph length, M. As tasks get more tedious, model accuracy drops significantly. Even top models fail when the text becomes very long. The poor performance on character counting, much lower than word counting, points to known weaknesses in how models process text at a sub-word level due to tokenization. The Unpuzzles dataset was created to expose memorization in LLMs by pairing 97 famous puzzles with simple, unpuzzled versions. Researchers observed reasoning delirium, where a model is triggered by familiar phrasing and misapplies complex logic from the original puzzle to the new, easy one. This leads to the surprising result that models perform better on hard puzzles than easy ones, suggesting their success comes from memorization, not problem solving. This table compares model accuracy on original puzzles, unpuzzles, and context-shifted unpuzzles for a 64-problem subset. Every model performed better on the context-shifted problems than on the unpuzzles, showing they are capable of the simple logic when not confused by familiar phrasing. This confirms that failures on unpuzzles are due to flawed, memorized responses, not an inability to reason. This work shows that advanced LLMs struggle with simple reasoning. Performance drops as tasks become more tedious, not just more complex. The Unpuzzles dataset reveals that models rely on memorization, often failing easy versions of puzzles they can solve. This reasoning delirium suggests we should evaluate models not just on the hardest problems they can solve, but also on the simplest ones they fail.